Oh, good day everyone. This is Chris again, and here back for another discussion. So today I'm going to talk about something related to chemistry somewhat. Well, certainly related to chemistry, but perhaps it would be better off discussed in say, a physics course. But we're going to go ahead and talk about it because it does really relate to chemistry and some of the interactions that we see that we've talked about, but we haven't really defined all that well. And what I'm going to do is just kind of preface this by talking about how things attract each other in an atom. And specifically what I'm talking about is how the nucleus attracts electrons or vice versa. What goes on? Well, obviously we know it's very complicated, but we'll just draw a very simple model so we can at least conceptualize in a general level what's going on. So if I look at, let's just take hydrogen for example, simply because it's a very easy atom to just kind of get a good visualization of. We know that the nucleus of hydrogen, there's a particle, or what we call a particle, and then in defined levels of energy surrounding the nucleus, we have an electrons. So I'm going to just draw an electron here, and again, it's not literally orbiting, but it's just somewhere inside of this general level of energy. You remember from the quantum numbers, you know, the n level, n equals 1, 2, 3, so on and so forth. Well, how does this electron know, or how is this electron attracted to the nucleus in the first place? Well, what do we know? We know that the nucleus is a proton. And what is unique about the electron and the proton? Well, there are obviously a lot of unique things, but what is the unique characteristic that kind of attracts the electron and the proton? There's something going on there, and what that is that's a concept known as charge. And what is charge? And I think a lot of us think, well, it's opposites attracting. Okay, yes it is. If you really think about what charge is, or if I really think about what charge is, I really can't give you a good definition of charge other than it's a characteristic. It's just a physical characteristic of certain particles that have this concept known as charge. And we know that if one particle has a certain type of charge and another particle has the opposite, we know that those two particles will then attract each other through this electrical force generated through the opposite charge. Now when we talk about protons and electrons, we just arbitrarily make up a name for that charge, and we say, well, an electron has a negative charge and a proton has a positive charge. Now that's pretty arbitrary. That doesn't really mean anything other than, well, the electron has a charge, and we'll put a number to that here in just a little bit, and the proton has a charge, and there's just there's basically just an opposite. One part positive charge, a certain number, one part negative charge, a certain number. And when I have that positive and negative, I have attraction. But I could just as easily have, you know, two electrons with the same type of charge, a negative and negative. And we know that, you know, if I brought two electrons together or two protons together with the same type of charge, and again, I wouldn't necessarily need negative and positive. I could call this green and yellow or blue and white. You know, I could arbitrarily assign any name I want to differentiate the type of charge, and you actually run into that when you talk about some of the quantum mechanics of the nucleus and kind of what holds protons and neutrons together, and actually the quarks inside of the protons and neutrons, and we realize that there's a certain type of charge, and we just arbitrarily basically assign color charge. So again, positive, negative just kind of makes it easier for us gives us a working framework that we can kind of visualize. But going back to this concept of charge, so if I have two electrons and nothing else around, I'm out in dead space, two electrons, and I find a way that I can push this electron toward that electron, well, what happens? Well, because of the same charge, they both have a negative charge, they're going to repel each other. There's going to be a repulsion going on. And likewise, if I have two protons, the positive charge, there's also going to be a repulsion going on. And let's say that I have an electron now and a proton kind of out in space. Well, we know that there is going to be some sort of force that wants to bring these guys together. They're going to be attracted to each other through this force. All right. So when we talk about the force, or the electrostatic force, can we really define it? And, well, we can't really. There are some theories out there, something called quantum field theory, where a particle with charge actually kind of creates a field around it. Kind of getting into some Star Wars type of stuff now, force fields and so on and so forth. But that is definitely a way that we can look at it, is that there's some sort of force because of that charge, and it goes on and on and on, and obviously the force is strong close to the electron, and then it kind of gets weaker and weaker and weaker as we go out. And it's actually these fields of force that these particles have created by the charge that allow these particles that aren't necessarily near each other to communicate, to let one electron know, hey, there's another electron around, and we are going to have a repulsion because we have the same charge. So understanding the fundamental aspects of these fields, or whatever it is, whatever mechanism exists in real life, I don't really think that we know at this point, what specific mechanism exists, other than some theories. So we can't really say for sure, what exactly is going on. But what we can do is we can measure that force, and we can quantitatively, we can put a number to that force that we measure. And here comes, basically, here comes the point of this whole presentation I'm doing, is how do we measure it, and how do we actually put some numbers to charged particles interacting? Well, there's something known as Coulomb's law. And I'll go ahead and just throw it out here for you. Go. Hopefully I didn't misspell that. So Coulomb's law. And Coulomb's law, and I'll go ahead and write it out, and I'll go ahead and describe it in just a little more detail. Coulomb's law basically says, or it states, that the force, and I'll just put a little line above that force, because that is a vectored quantity. The force equals, excuse me, 1 over 4 pi epsilon naught multiplied by the charge on my first particle, charge on my second particle, divided by the distance, the square of the distance between the two particles. Well, that looks pretty complicated, but actually it's a really cool formula because we don't have to derive it. We don't have to really do calculus with this. It's basically a plug and chug formula. And in the next discussion, I'll go ahead and break this Coulomb's law down a little bit. We'll put some numbers and we'll actually work with it and give ourselves a better idea of how this Coulomb's law works, and what is a Coulomb, how does it relate to charge on electrons, protons, and so forth. And I'm also going to talk a little bit about this R squared here, because this is actually a very profound concept when we talk about the electrostatic force. very profound, because there is another formula, basically, that we use to measure another kind of force. And as you guys may remember from nature, there are actually what we call the 4 fundamental forces of nature. And does the electrostatic force have something in common with some of the other forces? And is that potentially profound? And does that symmetry that these forces potentially share point to a deeper, more fundamental level of understanding of our universe? Perhaps so. All right, thanks again, guys.